Today's date is February 19th, 1985. As the residents of Madrid awake to a Tuesday morning like any other, on the ramp at the city's major international airport, Barajas, Iberia 610 is readied in preparation for its short domestic hop to the Basque city of Bilbao, a mere 45 to 50 minutes flying time to the north. Of the 141 passengers on board, the Bolivian Labour Minister González Guzmán and Spain's former Foreign Affairs Minister Gregorio López Bravo will be but two, augmented by 3 crew members on the flight deck and 4 in the cabin. Pre-departure procedures will be completed without incident, and at just after 8:30 local, the Boeing 727-200 series will commence its push from the stand. With the ground crew disconnected, the aircraft's trailing and leading edge devices will be configured for takeoff, and with the after-start checklist complete, a few short minutes after pushback, the ill-fated Iberia 610 will call for taxi clearance. In the days preceding the accident, a series of weather fronts will have crossed the Iberian Peninsula, moving in an easterly direction, mainly along the 40th parallel, bringing with them plenty of cloud over particularly the northern part of the country. The combination of a low-pressure area between the Gulf of Cadiz and Morocco to the south, and a very high-pressure area to the north over continental Europe, will result in an airflow from the northeast towards the Cantabrian mountain range, and a significant line of stationary cloud along the northern Spanish coastline. Satellite photography of the area around the time of the accident will indicate low cloud over the whole of the Basque region, although not necessarily forming a continuous layer. According to reports from observers at Bilbao Airport in and around the time of the accident, the sky will remain cloudy, some of this being low-level stratus layers of between 1,500 and 3,000 feet in thickness, with occasionally fragmented bases of between 2,500 and 4,000 feet above sea level. With that, a combination of relatively high humidity and the airfield's proximity to the Cantabrian Sea will give rise to reported mist, with visibility varying in the area from between 4 and 5 kilometres. The likelihood of this mist dissipating over the coming hours will be deemed unlikely due to the relatively light surface winds in the general area. To an experienced crew, as will be the case this morning, nothing in these reports will pose any operational challenge whatsoever, and in truth, they will have the expectation of it being just another day. Iberia 610 will finally lift off at 8:47 local. What nobody on board can know is that in exactly 40 minutes' time, while positioning for the approach to runway 30 in Bilbao. 610 will collide with a television mast on the summit of Mount Oiz, some 30 kilometres southeast of the airport, at an altitude of just under 3,400 feet. None of the 148 souls on board will survive. The accident was, and is to this day, nearly 40 years later, the worst disaster in the history of Spain's national carrier. This documentary will attempt to provide an insight into the workings of the 727, the events leading up to the crash, and the contributing factors which will all conspire to result in the loss of so many lives and the total destruction of a perfectly serviceable aircraft. This is an effort to tell the complete story of Iberia 610. The actual names of the crew will never be made public in the final report. However, information which will be released will state that the commander, aged 51, will have accumulated just over 13,500 hours flight time, just under 5,000 of which will have been on the 727 type. His first officer, aged 38, who it will be established was the pilot actually flying the aircraft for this particular leg, will have just over 5,500 total flight hours, just over 2,000 of which being on the 727. Situated to the rear of the flight deck and operating the flight engineers panel will be the third member of the cockpit crew. Also aged 38, his experience will extend to just under 3,000 hours, all of which has been gained on the panel of the 727. At 08:58 and 24 seconds, just 28 minutes and 39 seconds before impact, Iberia 610 will contact Madrid Eastern Control Sector on frequency 138.5 and report, "We are leaving 185 for 240 inbound to Domingo," this being a VOR navigation beacon about 50 nautical miles south of Bilbao. 610's time with the East controller will be short, as they will soon be handed off to the northern sector on frequency 13435. Madrid, Iberia 610, good morning. To which the northern sector controller will reply, 610, Madrid, good morning, radar contract. What level are you requesting? Meaning what level would they like to request for the brief period of cruise flight as they head north? 610 will simply reply, 26, meaning flight level 260 or the equivalent of 26,000 feet, with the controller immediately approving their request. 610 authorized for flight level 260. Okay, for 260, we are now leaving 215, thank you. At 092 and 18 seconds local, the altitude alert warning will be heard on the cockpit voice recorder, indicating to the crew that they are approaching their selected cruising altitude of flight level 260. As the aircraft levels, the first officer and flight engineer will engage in some light conversation, and during a period of low workload, the opportunity will be taken to call ahead on their second radio set to Iberia operations at Bilbao. Somewhat uncharacteristically, the first officer as pilot flying will also handle communications on the company frequency. I say uncharacteristically, as common practice throughout the industry would normally have the pilot flying concentrate exclusively on the handling of the aircraft, in so doing delegating all other routine tasks, including operation of the radios, to the pilot monitor. In fact, such was the level of radio communication from the first officer, even after this call ended, that initially some doubt existed as to who was the actual handling pilot for the sector. Regardless, as already stated, the first officer will provide operations in Bilbao with an estimated landing time, routine information regarding passenger load and any specific handling requirements, as well as a request for an updated weather report. In response, operations will inform him that the current weather at the field indicates a wind of 110 at 4 knots, visibility 4 kilometres in fog, few cumulus cloud at 2,500 feet, scattered stratocumulus cloud at 4,000 feet, with a surface temperature of 7 degrees, likewise a dew point of 7 degrees, and a QNH or sea level pressure reading of 1025 hectopascals. At 0909 and 29 seconds local, just 17 minutes and 34 seconds before impact, 610 will request descent clearance with the following interaction with ATC being recorded. Madrid, 610 ready for descent. 610, roger, cleared flight level 130, correction, 100. For 100, copied, leaving 26. Immediately the altitude alert warning is heard with the selection of flight level 100, the new altitude to which the aircraft has been cleared. At this point, the cabin crew member will enter the cockpit, and although her comments will be largely indistinguishable, from the first officer's reply, however, of 15 minutes, 7 degrees and fog, it can be assumed that she will be inquiring about the estimated landing time and general weather conditions at destination, so as to inform the passengers, which she will subsequently do via the PA in both Spanish and English. Between 0910:16 local and 0911:01, a second cabin crew member will be heard in conversation with all three cockpit crew, from which it will be deduced that she has brought in coffee which they had requested earlier. At 0912 and 13 seconds local, the CVR will pick up the sound of a radio receiver being retuned, and immediately after, the Morse identification of the Bilbao non-directional beacon will be heard. Throughout, no conversation will be recorded between the three crew members, only background chatter associated with other aircraft on the frequency. Finally, at 0915 and 55 seconds local, Madrid North will contact 610 and instruct them to contact Bilbao. Iberia 610, contact now, Bilbao approach 118.5, goodbye. At 0916 and 3 seconds, just 8 seconds later, the first officer will again be the one to establish communication with Bilbao. Bilbao Tower, good morning, 610. Iberia 610, good morning, go ahead. We are leaving 13 for level 100, 28 out. Roger, Iberia 610, one moment please. Iberia 610, you can continue descent for an ILS approach to Bilbao runway 30. Wind is 100 degrees 3 knots, QNH 1025, and transition level 70. Thank you, descending to sector minima with 1025. Correct, 1025, and if you wish, you can proceed direct to the fix. The altitude alert will sound one more time as the altitude target is reselected to 7,000 feet, the minimum safe altitude for arriving traffic from the south. What the controller will offer here is a shortcut, an opportunity for 610 to proceed directly to a point on the extended runway centreline at a distance of 13 miles from the Bilbao VOR, or just over 11 nautical miles from the threshold of runway 30. This was common enough practice at the time in an effort to better manage traffic flow efficiency. Noting the absence of any subsequent dialogue between the two pilots, it will be surmised by the investigators that through a hand signal or gesture of some kind, the captain will indicate his intention to decline the offer and continue with the more lengthy procedure which commences from overhead the Bilbao VOR beacon. We're going to make the standard manoeuver, to which Bilbao will simply respond. Roger. Notify passing over the VOR. At 0917 and 49 seconds, now just over 9 minutes before impact, the first officer will announce 10,000 descending, which will trigger the flight engineer to commence the 10,000 foot checklist, interacting with the first officer as he does so for a period of about 2 minutes. At 0920 and 23 seconds local, the altitude alert system will again sound, notifying the crew this time that the aircraft will be approaching the selected altitude for acquisition, that being 7,000 feet. Approaching the VOR, the first officer begins to slow the aircraft for its current speed of 260 knots, as he prepares to turn the corner and proceed outbound on the 121 radial in accordance with the procedure. At 0921 and 40 seconds local, 5 minutes and 24 seconds before impact, as the aircraft speed reduces, the first officer calls for the first extension of flap in order to augment the lift being produced by the wings. 2 please. The selection is made with the flight engineer confirming 14 seconds later. 2 green, 1-9 minimum, meaning that the inner and outer devices have extended to position 2 symmetrically and that the minimum speed allowed for this configuration is 190 knots. At 09:22 and 04 seconds, 5 minutes exactly to impact, the first officer again called the tower. 7,000 over the VOR Iberia 610, starting the manoeuver. The tower will acknowledge, without realising, that this will be the last communication from Iberia 610. Approaching Bilbao, the terrain to the south provides for a minimum safe altitude of 7,000 feet. What this means is that within this sector of radius 25 nautical mile from the Bilbao VOR navigation beacon, a floor of 7,000 feet will provide a 2,000 foot buffer above the highest terrain in the area, which is incidentally shown here at 4,921 feet. But a prohibition on descent below this value simply isn't feasible, since every plane at some stage has to make an approach and landing. So in order to navigate an obstacle-free path to touchdown, one of 2 scenarios must play out. Firstly, and probably the most common, particularly in developed aviation environments, is the provision of radar vectors. In this instance, air traffic control will provide lateral and vertical guidance to flights in order to successfully navigate around known terrain. Secondly, where radar is not available, or in the case of a radar failure, published procedures can also again provide for both lateral and vertical guidance provided, and this is important, provided that the crew adhere rigidly to the charted minimum altitude and prescribed lateral tracks. Any deviation on the part of the crew away from the charted procedure, either laterally or vertically, will inevitably bring the aircraft into an area which has not been swept for adequate terrain clearance, with the associated risk involved being a potential collision with the ground below. Having previously declined air traffic control's offer of proceeding direct to the 13 DME fix for a straight-in approach to runway 30, the aircraft will instead proceed to the Bilbao VOR and, per the published procedure, once overhead at 7,000, turn to the southeast and follow radial 121, essentially approaching the same 13 DME fix but from a northwesterly direction. Once established on this radial outbound from the VOR, and providing that the aircraft doesn't deviate laterally, then it will be safe to descend from 7,000 feet to 5,000, with adequate terrain clearance being guaranteed. Overhead at 13 DME fix, the aircraft will turn to the left and proceed on a track of 076 degrees. This track will be maintained for 60 seconds, while simultaneously descending from 5,000 feet to no lower than 4,354 feet. The reason this figure is so precise relates to the mandatory 1,000 foot buffer it provides from the highest terrain in the immediate area. With the 60 seconds having elapsed, the aircraft will commence a right-hand reversal turn back onto a heading of 310 degrees in order to establish the correct inbound course to the landing runway. Having descended to 4,354 feet, this altitude must be maintained until interception of the ILS glide slope, which will ensure adequate terrain clearance along the remaining approach path all the way to touchdown. In order to understand why Iberia 610 will find itself below the minimum safe altitude stipulated for the procedure turn, that being 4,354 feet, it'll be important to become familiar with certain aspects of the altitude selection, alerting, capture criteria, and finally altimeter presentation as they pertain to the Boeing 727, and in particular the specific 727 involved in this accident. As the aircraft will be flown with the autopilot engaged at the time, we'll discuss the relevant issues in that context. When the crew of a 727 receive a descent clearance, or alternatively the aircraft has been cleared to descent with the procedure, the following sequence of events will occur in the cockpit. Firstly, having acknowledged the clearance, the pilot flying will set the altitude selector to the new revised altitude. The example shown depicts the crew reselecting the altitude selector from 7,000 to 5,000 feet, as will be the case with Iberia 610 passing overhead the Bilbao VOR and tracking outbound on the 121 radial. The altitude selector is usually parked in the thousands position, meaning that for part rotation of the selector knob, the altitude readout in the window will change by 1,000 feet. Where smaller altitude changes are required, a finer tuning selection may be commanded, where the equivalent part rotation of the selector will now instead change the altitude in the window by 100 feet. It's important to note that the minimum unit by which the altitude selector can be changed is this 100 feet. Therefore, by way of example, where an altitude of 2,250 feet is required, the selector would have to be set to 2,300 feet in order to avoid a deviation below the minimum stipulated altitude. Our focus here being on the procedural letdown into Bilbao runway 30, our scenario will concentrate on the aircraft in descent. However, the description of events which follow is equally valid in the case of a required climb to a new selected altitude. Regardless of the intention, be that a climb or a descent, once the new altitude is selected, as you've heard, a momentary aural alert is triggered, with illumination of the associated altitude alert light. This will indicate to the crew that a discrepancy now exists between the altitude the aircraft is currently at and the intended altitude to fly, that being the one indicated in the altitude select window. Coincident with this initial alert, the aircraft's altitude alerting system will now switch to acquisition mode. In this acquisition mode, once the initial alert extinguishes, the system remains silent until such time as the aircraft's closure to the newly selected altitude reduces to a value of 900 feet. At this point, be it in descent or climb, a second aural and visual alert is triggered, indicating to the crew that the aircraft is approaching the newly selected altitude. The aural attention grabbers will last for no more than about 2 seconds, while the visual attention grabbers, by way of a steady amber light in the direct view of each pilot, will remain illuminated until the aircraft descends or climbs to within 300 feet of the new altitude. Shortly thereafter, the 727 will enter the engagement mode, where the autopilot will reduce the rate of climb or indeed descent in order to ensure an acceptable G-loading in the cabin as the aircraft levels off. The previous steady amber alert light in front of both pilots will now extinguish as the aircraft closes to within 300 feet of the new altitude, being replaced by a steady green indicator light as the aircraft transitions into the engagement phase. Of fundamental importance, however, and of huge significance in the demise of Iberia 610, is the fact that for this engagement mode to be triggered, resulting in acquisition of the new altitude, the pilot must make a conscious and deliberate action to arm altitude capture. Difficult as it is to believe, particularly when compared to the workings and logic of modern-day autopilots, the 727's autopilot would simply not recognise a need to capture and maintain the new altitude unless it was specifically told to do so. In order to arm the system for acquisition of the new altitude, the pilot will have to press the altitude select push button on the autopilot panel, which is located on the centre cockpit pedestal between captain and first officer. When pressed, an internal amber light will illuminate, indicating its armed status. It's also through this panel that the pilot flying will select which of the available pitch modes is most appropriate under the circumstances to initiate the climb or descent to the newly selected altitude. The indicator panel in front of each pilot will likewise show that the engagement mode has been armed through illumination of the amber altitude select light. As the aircraft continues to close with the newly selected altitude, once the engagement mode is actually triggered, these amber alert indications will both change to green. The point at which this engagement mode becomes active very much depends on the aircraft's closure rate with the selected altitude. For example, at a closure rate of about 1500 feet per minute, the engagement mode will be triggered at about 230 feet before reaching the new altitude. Increase that rate of closure to 7,000 feet per minute, and the engagement mode is armed accordingly to trigger at 650 feet from the selected altitude. As the engagement mode modifies the aircraft's rate of closure with the newly selected altitude, eventually the altitude hold mode will be triggered within about 40 feet of the target altitude. With the altitude hold mode now active, all altitude-related lights on the autopilot panel will extinguish, as will the green engagement lights in front of the two pilots, to be replaced by the steady green altitude hold indication instead. Along with the acquisition logic we've just examined, the alerting system also has a deviation logic to alert pilots to the fact that the aircraft, for whatever reason, is not adhering to the assigned altitude. In a situation where the aircraft unintentionally deviates by more than 300 feet from the selected altitude, an oral alert is triggered, along with the flashing illumination of the amber altitude alert lights. Although the oral alert is relatively brief and transitory, the visual alerting, in contrast, will continue until the magnitude of the deviation exceeds 900 feet. So how does this all pertain to Iberia 610? Well, the following is a reconstruction of what will most probably be actioned and experienced by the crew of 610 as they approach the Bilbao VOR, maintaining 7,000 feet and preparing for the right-hand turn to establish on the 121 radial outbound. Having passed overhead the Bilbao VOR, the altitude selector will be reset to 5,000 feet, once again triggering the altitude alert visual and oral indications. The altitude capture mode will be armed, and at 09:23:14 local, just 3 minutes and 50 seconds prior to impact, the aircraft will leave 7,000. From the time they leave 7,000 until capturing 5,000 feet, the aircraft will descend at a rate of 1,000 feet per minute. Slight course corrections will be recorded as the aircraft navigates the 121 radial from the VOR to the southeast. Then at 09:24, the first officer will be heard to announce, "We'll set the seatbelts now." And immediately he will select the seatbelt sign on, triggering the cabin crew to make the appropriate PA some 11 seconds later. Again, both in Spanish and English. At 09:24 and 27 seconds, the altitude alert horn will again be heard on the cockpit voice recorder as the aircraft descends through 5,900 feet, just 900 feet prior to acquisition of the selected altitude. At 09:25 and 14 seconds, just 1 minute and 50 seconds prior to impact, Iberia 610 will capture 5,000 feet and maintain this altitude for a further 25 seconds. During this period, the airspeed will slow from 209 to 203 knots. 9 seconds before leaving 5,000 feet, at 09:25 and 30 seconds local, 1 minute and 34 seconds before impact, the altitude alert will sound again, most probably as the crew reselects 4,300 as the next altitude for acquisition. On reaching the 13 DME fix, the aircraft commences the left turn onto 076. The altitude chosen, however, will draw comment from the subsequent investigation team. As stated previously, the altitude selector in the cockpit allows for selections in the magnitudes of thousands and hundreds of feet. Therefore, with the minimum altitude for the turn being published at 4,354 feet, in order to prevent a descent to an altitude below this value, the crew will have to set 4,400 feet as the altitude for acquisition in the altitude selector window. Detailed examination of the selector, which was recovered post-crash, however, confirmed that 4,300 had in fact been set. Although with the defined buffers in place, the magnitude of this misselection will in reality prove inconsequential and ultimately play no part in the events which will follow. As the descent from 5,000 commences, simultaneously the aircraft will make the left-hand turn onto a track of 076 degrees, and established in the descent will maintain a vertical speed of 1,500 feet per minute, arguably excessive given the relatively little altitude to be lost, but which will be held nonetheless until reaching an altitude of 3,870 feet, some 48 seconds later, and some 484 feet below the minimum altitude stipulated for the turn, where the rate of descent will be adjusted to 700 feet per minute and maintained as such until impact with the telecommunications tower on the summit of Mount Oiz. The more significant issue here, and most likely not truly appreciated by the crew, will be that regardless of whether 4,400 or 4,300 will be ultimately selected, the planned change in altitude will be less than the 900 feet which is necessary in order to trigger the altitude alerting system as the aircraft closes with the newly selected altitude. As such, the crew will hear one alert as the selected altitude is changed to the new revised target, but no second alert as the aircraft approaches the new altitude, as would normally be the case. From a visual perspective, the altitude alert light will stay illuminated steady amber until within 300 feet of the newly selected altitude, in this case about 4,600 feet above sea level, and although present, may well be interpreted by the crew as the initial alert of the new altitude having been selected. As covered previously, under normal circumstances, the crew would expect to hear and see appropriate alerts as the aircraft closed to within 900 feet of the selected altitude. However, as we've also highlighted, due to the circumstances here, with descent from 5,000 to 4,300, such alerts will not be presented to the crew. That said, irrespective of the altitude alerting system, it is anticipated that the engagement mode should nonetheless activate and the aircraft begin to modify its rate of descent in expectation of capturing and maintaining this new altitude. However, in the case of Iberia 610, for some as yet unknown reason, this will also fail to happen, and the aircraft will continue to descend below its minimum safe altitude. In attempting to understand exactly why, the subsequent investigation will speculate that the engagement and altitude capture modes, ensuring that the aircraft will acquire and hold the preset altitude of 4,300, will either never be armed or alternatively, having been armed, will be inadvertently disarmed at a later stage, and that subsequently this will go unnoticed by the crew. The significant question is what events could possibly contribute to this potential outcome. As the investigation body will ultimately set about its work, it will rationalise that failure of the autopilot to acquire the selected altitude could potentially result from any of the following scenarios. Firstly, if the vertical speed selector is moved once the engagement mode has already become active, the altitude capture mode will automatically be disarmed and the aircraft will simply maintain its current rate of descent. Assuming that it will be armed in the first instance, this scenario is clearly plausible, especially when the evidence will suggest that the first officer as pilot flying will be quite diligent in arming the altitude capture mode with each previous descent clearance. Secondly, if the first officer as pilot flying were to delay arming the altitude capture mode until a time where this action would be coincidentally aligned with the aircraft's passing through the altitude appropriate to activation of the engagement mode, then the engagement mode itself would be deactivated, as the instruction to capture the revised altitude would have been received too late. In this instance, as before, the aircraft would maintain its current rate of descent and the target altitude would not be acquired. The same will be true if the altitude capture mode were to be armed below the selected altitude, in this case below 4,300 feet. For either of these scenarios to be considered plausible, it would be reasonable to assume that the pilot flying would have to be distracted somehow, causing his delayed execution of the procedure. In truth, however, nothing on the cockpit voice recorder will support such a hypothesis. In fact, examination of the first officer's actions on receiving previous descent clearances will indicate that he will be consistently proactive in implementing the necessary procedures in a timely fashion. The third potential reason for the aircraft not acquiring the selected altitude of 4,300 would be where the autopilot was disengaged for whatever reason, be that deliberate or otherwise. Of note, should the autopilot be inadvertently disconnected and then subsequently re-engaged, the altitude capture mode would have to be rearmed. Failure to do so would result in the aircraft continuing its descent through the selected altitude. Again, cockpit voice recorder transcripts reveal no evidence of autopilot disengagement, deliberate or otherwise. The fourth potential scenario, and one of the more plausible in my own personal opinion, is where the altitude capture mode was armed, but the button was inadvertently pressed a second time, disarming the mode, which simply went unnoticed by the crew. Or finally, however unlikely, to accept the fact that possibly the altitude capture mode simply failed for some unexplained reason. Regardless of why the autopilot will fail to capture the selected altitude of 4,300 feet, the fact is that it won't. Having missed their deviation through the selected altitude, what happens next, although subtle, will have the effect of fooling the crew into believing that all is as it should be. As the aircraft deviates away from the selected altitude, in this case at about 4,000 feet, the altitude alerting deviation logic will be triggered. As mentioned previously, this will generate an audible alert tone on the flight deck, identical to the tone which the crew would have expected to hear as the aircraft closed to within 900 feet of the newly selected altitude. As they hadn't previously heard this with their closure to 4,300, by virtue of the fact that the descent had been commenced from an altitude within this 900-foot tolerance, investigators hypothesized that the crew interpreted this as a warning that they were closing on their selected altitude, rather than actually deviating away from it. In support of this opinion, the investigators pointed to the first officer's action in reducing the rate of descent with enunciation of the alert, this being consistent with his previous actions throughout the descent profile. The investigation team argued that the first officer was of the belief that he was approaching his selected altitude of 4,300 and was taking appropriate steps to ensure that the immediate level off would be as smooth as possible. Admittedly, the visual alert to the crew in this case of a deviation away from the selected altitude would be a continuous flashing rather than a steady amber light directly in their line of sight. That said, however, be it due to high workload, complacency, or simply unfamiliarity with the finer points of the alerting system, this never registered with any of the three pilots on the flight deck. They simply saw what they expected to see, being convinced of what they thought they knew. Why was it so difficult for any of the three experienced crew members to rationalize that their current reality was something completely different and not what they had expected? As is true of most aircraft accidents, each is usually the sum of its parts, and in this regard Iberia 610 is no different. The autopilot's failure to acquire the selected altitude of 4,300 feet will retrospectively be a devastating statement of fact. However, the reasoning behind the crew's failure to recognize their continued descent may be due in no small part to the altimetry instrumentation which was fitted to the Iberian 727s. Although modern airliner altimetry displays are designed cognizant of significant amounts of human factor research into the subject matter, the situation back in the mid-80s was somewhat different. The design of such instruments at the time largely prioritized their practical application, with little regard or understanding of how exactly the human at the controls would actually process the information which the instrument was portraying. In a word, ergonomics, or the scientific discipline concerned with the understanding of interactions between humans and the working environment they find themselves in. During the 80s, a number of different altimeters were in common use, these primarily being the triple pointer altimeter, the counter pointer altimeter, the counter drum pointer altimeter, and of specific relevance to Iberia 610, the drum pointer altimeter. The drum pointer device as shown here reflects the design of altimeter fitted to the accident aircraft. To explain its operation, as the pointer passes through one complete revolution, it will express a change in altitude of 1,000 feet. The face of the instrument is subdivided into 10 equal segments, each representing an altitude change of 100 feet, with these segments themselves being further subdivided into 5 equal parts, so that the smallest expressed measurement of altitude change is actually 20 feet. However, in order to assess the number of thousands of feet the aircraft is currently maintaining, it's necessary to read this information from a small revolving drum located on the right-hand side of the instrument, which revolves continuously against a fixed pointer. The definition of a good instrument is one which is easy to read and offers to the pilot the information which he seeks and needs. The airspeed indicator, for example, may be considered a good instrument, as it requires just one look for it to be read and provide all the relevant information the pilot needs. In contrast, however, the drum pointer altimeter is most probably not a good instrument, insofar as it requires a double look, if you like, in order to assess all the information it has to display. Once to assess the pointer, and a second to assess the drum. There are occasions where both can be read at the same time, while others, particularly where the pointer overlaps the drum, where only some of the information is readable. A study conducted by NASA entitled How a Pilot Looks at Altitude and dated 1981, some 4 years prior to the accident, made the following observations. The current altimeter design are not totally adequate, as evidenced by the number of accidents, near accidents and incidents attributed to altimeter misreading by pilots. It further went on to state that if altimeter display improvements are to be accomplished and if optimum altimeter displays are to be developed for future flight system, it becomes imperative that we must understand the problems with existing altimeters and how a pilot obtains and perceives altitude information. It was this, therefore, which provided the stimulus and motivation for the undertaking of the study. Although cognizant of the variety of altimeters in use at the time, this particular study focused specifically on the drum pointer altimeter, as fitted to Iberia 610. The report makes reference to a survey conducted by national airlines in the United States, whereby they had attempted to ascertain the percentage of their pilots who had misread or observed other pilots misread the drum pointer altimeter, as fitted to their fleet of 727 aircraft. Of the 169 respondents, 137 stated that they themselves had misread the altimeter, while 134 stated that they had observed another pilot make the same error at one time or another. Indeed, 85% of each group stated their experiences were not confined to one single event. The results also indicated that the surprisingly large number of misreads, 50 in total, happened during the approach phase of the flight. Typical of the comments submitted by the pilots who undertook the survey were the following. This altimeter takes more concentration than should be necessary to read accurately. The small drum window is a complication on the instrument, and quite small, often requiring a double look and diverting attention away from the needle. Other instruments require only a single point of visual attention to comprehend, and do not divert, slow, or complicate a smoothly flowing scan. With regard to the impact high workload can potentially have on the crew's interaction with this instrument type, one comment read, "Misreads seem to always occur at the lower altitudes when attention is split between more activities." Likewise, in the same workload context, another pilot reported, "The more stressful situations produce more misreads." And finally, in what summarizes the design complications of the device, one pilot reported that a quick glance, having been distracted, can usually induce a reading of 1,000 feet off if the barrel drum is halfway between thousands. All in all, a summary of the comments received would suggest a design which posed numerous operational challenges to those forced to work with it. Furthermore, data collection from simulator exercises and experimental test flights would seem to validate these pilots' experiences. When studied, it became obvious that when a pilot directed his attention towards the altimeter, one of 3 possible behavioral patterns was observed. Where the pilot merely glanced at the instrument in order to ascertain an altitude trend, This action was not surprisingly completed in the shortest period of time, on average within 1/10 of a second. In order to read and comprehend exactly what the pointer was saying, again not surprisingly took on average an additional 2/10 of a second. However, what was noticeable was that where the drum values were scrutinized, indicating the thousands of feet altitude the aircraft was actually flying, dwell times increased by a factor of 2. Yet the corresponding attention time given to drum information was less than 10% of that given over to glancing at or reading of the pointer indication. In other words, in using the drum and pointer altimeter, several visual fixations within the instrument were necessary in order to process all available information. It was largely for these reasons, given the phase of flight and the crew's relatively high workload, that the subsequent investigation believed the crew of 610 failed to notice the autopilot's inability to capture the selected altitude of 4,300 feet. In addition, however, the investigators also noted some interesting behavioural patterns which they also believed may have been contributed to the accident. They drew attention to the fact that the pilot's monitoring patterns are very much influenced by whether the aircraft is under manual or automatic control. They cited proof that with autopilot engagement, monitoring patterns tend to be faster by definition, of shorter fixation. This increased speed, however, often comes with a trade-off in accuracy. In other words, one of the two scenarios may result. Either the pilot's appreciation of the aircraft's position becomes less accurate when under automatic control, or detection of significant deviation will become less likely when compared to situations where the aircraft has been flown manually and responsibility for such deviations or positional errors is being directly attributed to the pilot's actions themselves. A second consideration the investigators raised was that of psychological uncertainty. They maintained that uncertainty of one's position or condition grows with time from our last examination of the relevant parameter. For example, when descending from an initial known altitude at a given rate of descent, the pilot may well feel confident in the aircraft's vertical position without constantly referring back to the altimeter itself. Indeed, simulator evidence has shown that despite pilots believing that the altimeter is one of the most important instruments in the cockpit and is afforded attention accordingly, the reality is completely different, with less than 3 to 6% of the time flying an ILS approach being dedicated to exclusive interrogation of this instrument specifically. What this study shows, therefore, is that knowing their specific starting point, pilots are far more likely to assess altitude deviation through alternative means, namely flight director commands, changes in vertical speed, verbal inputs from the pilot monitoring, or indeed from altitude alerting devices, rather than from direct interrogation of the altimeter itself. It was for this reason, therefore, that they also hypothesized that poor monitoring practice and over-reliance on automation may well have been a contributing factor in the crew's failure to recognize their descent below the minimum safe altitude published for the turn procedure. With the final critical manoeuvring of the aircraft into the right-hand turn to commence at 09:26 and 54 seconds local, exactly 10 seconds before impact, the first officer will call for the next extension of flaps. 5 please. Followed 2 seconds later with confirmation of the revised minimum manoeuvring speed in this new configuration and a reminder of the minimum altitude specified for the turn. A minimum 163, 4,300 curve. Whether this statement might have prompted the crew to re-evaluate their situational awareness will forever be speculative. 3 seconds later, at 09:27 and 4 seconds local, the aircraft's impact with the telecommunications tower will be recorded on the CVR as Iberia 610 is lost. About 40 minutes after its last communication with Iberia 610, Bilbao Tower received a phone call confirming that the aircraft had indeed been lost. Of the little information known in the immediate aftermath, what was apparent was that the 727 had struck the television tower of Euskal Telebista at a height of 3,370 feet above sea level, at position 43 degrees 13 minutes 43 seconds north, 2 degrees 35 minutes 26 seconds west, some 30 kilometres southeast of the airfield, while self-positioning for the ILS approach to runway 30. Over time, it was later established that the aircraft had been configured with both gear and flap 5 extended in a 29-degree right bank turn, which had been commenced only 10 seconds earlier. Descending at 600 feet per minute with an indicated speed of 208 knots or 385 kilometers per hour, it was established that the engines were operating normally but at a low power setting, with the autopilot remaining engaged throughout. The antenna, at 54 meters in height, was struck about 3/4 of the way up, with the initial contact point being at the bottom of the left part of the aircraft's nose. Examination of the wreckage revealed a continuous graze along the underside of the left forward fuselage, resulting in damage to the left wing and door assembly of the nose gear mechanism and superficial structural elements as the fuselage was opened. With the relevant contact point between aircraft and antenna continuing to move rearward, eventually the leading edge of the left-hand wing was to make contact with the structure. The force of the collision was such as to cause the main spar of the wing to be compromised, with the wing being completely sheared off. Detached from the aircraft, it continued in the same direction of travel as it made contact with the mountain, finally coming to rest some 620 meters from the base of the antenna. As for the rest of the aircraft, having lost the left wing completely, the disproportionate lift being produced across its span now caused it to roll rapidly and uncontrollably to the left. It followed a parabolic trajectory in the vertical plane while continuing the same longitudinal direction of flight, eventually impacting the mountainside completely inverted and coming to rest at a distance of 930 meters from the base of the antenna. Its path along the ground raised pine forest ahead to the tune of 20,000 square meters, leaving in its wake remains of the tail and front fuselage sections, as well as parts of the left number 1 engine. The main wreckage, including the nose gear, right-hand main gear, engines 2 and 3, as well as the rear part of the fuselage, continued into the lower part of the valley below. There was no evidence of widespread fire post-impact. However, localized fires did break out as a result of the compromised fuel tanks dispersing their content onto the wreckage, most notably in the vicinity of the tail sections and engines. The accident was unsurvivable. In closing their investigation, the Spanish investigation team would draw the following conclusions. The functioning philosophy of the 727's altitude alerting system does not negate the crew's responsibility to monitor correct autopilot acquisition of selected altitudes. As such, with the autopilot's failure to capture the final and minimum published altitude for the procedure, the last 57 seconds of the flight were flown below the minimum safe altitude, with navigation only possible by sole reference to the aircraft's flight instruments. They were of the opinion that there was insufficient monitoring of the manoeuver by the non-flying pilot, who failed in his duty to make the standard 1,000-foot callouts as the aircraft approached each newly selected altitude. The crew misselected the final altitude for acquisition as 4,300 feet. In view of the fact that the minimum safe altitude was published as 4,354 feet, the correct selection, in order to protect the obstacle clearance buffer, should have been 4,400. As a matter of fact, the telecommunication antenna's base surpassed the summit of Mount Oiz by 28 meters, despite the fact that it did not appear on any navigational chart. In exceeding the elevation of the mountain top, the necessary buffer guaranteeing obstacle clearance should have been predicated on it, and not, as was the case, the recorded height of the mountain's peak itself. Therefore, it was their ultimate belief that the root cause of the accident could be described as follows. Over-reliance on the automatic altitude capture performance of the aircraft's autopilot, the misinterpretation of the altitude alerting system, as well as a probable misreading of the aircraft's drum pointer altimeter, all contributed in allowing the crew of Iberia 610 to descend below the published minimum safe altitude in instrument meteorological conditions. This resulted in collision with the telecommunications tower on the summit of Mount Oiz, whereby the aircraft lost its left wing. Separation of the wing resulted in departure from controlled flight and subsequent impact with the terrain below. On the strength of these findings, they would subsequently make the following recommendations. The need to reiterate to crews the necessity and importance of performing the relevant callouts when approaching newly selected altitudes, particularly in the context of the pilot monitoring's responsibility for overall flight safety. The need to reiterate to crews the fundamental importance of crew resource management. The need to substitute the drum and pointer altimeter with other models which will mitigate the possibility of misreading errors. And where such altimeters persist, highlight to crews the very real danger of misreading, in particular the drum part of the instrument. With regard to 727's altitude alerting system, a review should be carried out in relation to its operational logic, with emphasis on synchronization of oral and visual alerts. In the context of altitude selection for alert and acquisition, subject to aircraft design limitations, such selections must always be rounded up and never down in order to ensure correct obstacle clearance is maintained. Furthermore, in relation to autopilot operational logic, review should be carried out to examine the feasibility of making the function of altitude capture completely autonomous and not reliant on dedicated pilot action. And finally, a recommendation to urge the appropriate aeronautical authority to accelerate the modification of aeronautical charts to comply with ICAO document 8168, and also to urge the appropriate aeronautical authority to assure periodic inspection and review of published minimum safe altitudes in order to accommodate newly constructed structures. Both these recommendations stemming from the failure to correctly amend the published minimum safe altitude with erection of the telecommunications tower on the mountain's summit. And so ends the story of Iberia 610, lost in the early morning hours of February 19th, 1985.